So like what I said in the email, instead of a lecture today, I'll be doing a review session. And this is just the first part of the review session. Our next review session will be on our next meeting. So let's do this first problem. We want to evaluate the integral of cosine of ln of x. So for this problem, I think the best method to use immediately is to the integration by parts. So in here, we let u be equal to cosine of ln of x, and then we let dv be equal to dx. And then from here, what is our du? Du, so the derivative of cosine of ln of x, this is equal to negative sine of ln of x dx. But with chain rule, derivative of ln of x, it's 1 over x. So we have an over x in here. And then for the dv, we have v equals x. So with this, we can now have uv. So we have x cosine of ln of x minus the integral of v du. So integral of negative sine of ln of x divided by x, and then you have x dx. And notice that this guy here we can simplify. We can cancel the x and x here. And then of course we have here minus and minus, so we'll just have plus. So this guy here becomes x cosine of ln of x plus the integral of sine of ln of x dx. And then we have this integral here, and we can use another integration by parts. So if we do that, let's say we now have here u sub 1 equals sine of ln of x, and our dv is still dx. So we will have the u sub 1, this is equal to cosine of ln of x, again over x by chain rule dx, and then v equals x. So we use dv1 and then v1. Yes? Any questions? No question? So continuing, we have this. We just copy this part here. We have x cosine of ln of x. And then for this, we use these substitutions. So plus u1 v1. So we have x cosine, or x sine of ln of x, and then minus integral of v1 du1. So integral of cosine of ln of x over x, and then times x, and then we have the dx. Okay? And of course, if we simplify this guy, we will have x cosine of ln of x plus x sine of ln of x, and then minus integral of cosine of ln of x dx. Okay? Okay? And notice this guy here, we have minus, and then that's actually our original problem. So let us just rewrite this. What we have is the integral of cosine of ln of x dx. This is equal to x cosine of ln of x plus x sine of ln of x minus the integral of cosine of ln of x dx. So if we bring this integral on the right-hand side to the other side, we'll just have twice this integral equals this guy here. Okay? So we will end up with 2 integral of cosine of ln of x dx. This is equal to x cosine of ln of x plus x sine of ln of x. And then we just need this integral here, so we divide everything by 2. And therefore, we will have the integral of cosine of ln of x dx. This is equal to x cosine ln of x plus x sine ln of x all over 2. And then let's just write that arbitrary constant c. So this is the final integral. Okay? Questions? Okay. Next problem. So we want to integrate square root of 4x squared minus 9 all over x squared. So if you look at this is of the form u squared minus a squared. Okay? U squared minus a squared. Meaning, we will use secant substitution. Okay? So let us just rewrite this as the integral. You have 2x quantity squared, then minus 9. Okay? And then in here, we have all over x squared dx. Okay? So we can let u be equal to 2x. Okay? Actually, let's just set this 2u or this 2x. We set this 2x equals 3 secant theta. Okay? Because if we do the square in here, so this implies that 4x squared, this is equal to 9 secant squared theta. And then from here, or from here, we calculate x squared. Okay, we calculate x squared. So from this guy, we have x squared equals 9 secant squared theta over 4. Meanwhile, from this guy also, we get the derivative. So in here, we have 2 dx. This is equal to 3 secant theta tangent theta d theta. Okay? Or your dx is equal to 3 halves secant theta tangent theta d theta. Okay? Which means using these substitutions, we have the integral. So for this, we will have 9 secant squared theta minus 9. We get the square root of this. On the denominator, we have 9 secant squared theta over 4. And then the dx here, we have 3 halves secant theta tangent theta d theta. Okay? And then this guy here, we can simplify. We can factor out 9. And then we take the square root of 9. Okay? So we will get here integral of 3. And then we will have here secant squared minus 1. And that's just tangent squared. So the numerator becomes 3 tangent theta. Okay? And then, let's see, we still have this guy here. Okay? So over 9 secant squared theta over 4. Then in here we have 3 halves. You know what? Let's cancel the secant and one of the secants here. Okay? And also let's cancel the 2 and the 2 in here. Okay? So let's do that cancellation. So here you have the secant theta. The denominator here, it's just 2. So what remains from this part is 3 tangent theta. And then we have the d theta. And then we have this 3 and 3 in here. So that's 9. So it will cancel the 9 in here. And then we have the denominator 2 on the denominator also. So we can simplify this now into 2 tangent squared theta over secant theta d theta. Okay? And then from here, what we can do is to convert this tangent squared theta to in terms of secant. So this becomes the integral of 2 secant squared theta minus 1 and then all over secant theta d theta. And then let's just simplify this. I'll take out the 2 and we will be left with the integral of secant theta minus 1 over secant theta d theta. And secant theta, 1 over secant theta, it's just cosine theta. So we have 2 integral of secant theta minus cosine theta. And then we have the d theta. And this guy here, it's easily integrable. Okay? So we have 2 times integral of secant theta. It's ln of the absolute value of secant theta plus tangent theta. Correct? And then, of course, integral of negative cosine theta, that's sine theta. So you have sine theta in here, and then you have d plus c. Okay? And then we now bring back the variable x. So from this guy, of course, from this guy, this means that we have secant theta equals 2x over 3. Or we have cosine theta equals 3 over 2x. Okay? So if we use right triangles, if this is our theta, cosine theta equals 3 over 2x, so katowa. So this guy here, this is the adjacent side. So we have 3. This guy here, it's the hypotenuse. So this is your 2x. And since we will need tangent theta or sine theta, we need the opposite. But this opposite, it's just your 4x squared minus 9. And therefore, this integral now becomes 2 times ln, absolute value. Secant theta, it's this guy. So you have 2x over 3 plus tangent theta, towa, opposite over the hypotenuse, opposite over the adjacent. So this is square root of 4x squared minus 9 over 3. And then plus sine theta, that's so. So this is your opposite. We have square root of 4x squared minus 9 over the hypotenuse, which is 2x. And then you have the plus c. So this is your final answer. This should be minus. And also this part here. So we have minus here and minus here. Okay. We want to integrate 5 minus 3x all over 2x squared plus 5x minus 3 dx. So this is a rational expression here. Obviously, we need to use integration by partial fractions. Okay? So, if we factor this, which is factorable, I suppose, this guy here, 2x squared plus 5x minus 3, this can be factored into, so we have the 2x here, and then we need a 3 in here, we need a plus in here, and then we have minus 1 in here. So you will get what? 2x times x, that's 2x squared. 2x times 3, that's positive 6x, minus 1 times x, that's minus x. So 6x minus x, that's your positive 5x. And of course, negative 1 times 3, that's negative 3. So this guy here, we can rewrite this as follows. 5 minus 3x all over 2x minus 1 times x plus 3. So this is equal to a over 2x minus 1 plus b over x plus 3, or this is equal to a times x plus 3 plus b times 2x minus 1 all over 2x minus 1 times x plus 3. So we have 5 minus 3x equals a times x plus 3 plus b times 2x minus 1. And then let's just substitute x equals negative 3. So if x equals negative 3, this guy here will disappear. And we will have this 5 minus 3 times negative 3. This will be equal to b times 2 times negative 3 minus 1. Here you have 5 minus negative 3, or 5 minus 3 times negative 3, so 5 plus 9. So we'll get 14. And then in here you have negative 6 minus 1. That's negative 7. So we have negative 7b, or we have b equals negative or positive 2 or negative 2. Okay? And then to get a, we substitute x equals 1/2. So if x equals 1/2, on the left-hand side, we have 5 minus 3 times 1/2. On the right-hand side, we have a times 1/2 plus 3. And this will be become 0. So in here, you have 5 minus 3/2. Plus in here you have, or sorry, this is equal to, in here you have 1/2 plus 3/2. So that will be 7/2. And then in here, this is actually 7/2, which means that a equals 1. Therefore, our integral now becomes the integral of a, which is 1. So 1 over 2x minus 1. And then b, it's minus 2. So we have minus 2 over x plus 3 dx. So if we do the integration, this is just ln of the absolute value of 2x minus 1 all over 2 minus, in here we have 2 times ln of absolute value of x plus 3 plus the arbitrary constant c. So we have this. So for this problem, instead of doing the usual methods, I mean the methods that we taught at the beginning of the course, what we will do is to use power series. Particularly, we will write e to the x as a power series. So we recall that your e to the x, the Maclaurin series representation of e to the x, this is just the sum from n equals 0 to plus infinity x to the n over n factorial, and the equality holds for all x in the set of real numbers. And furthermore, we will expand this. So we write this as 1 plus x squared over 2 factorial, which is just 2, plus x cubed over 3 factorial plus ... So we use this representation to evaluate this. So this integral now becomes the integral of 1 over x times 1 plus x squared over 2 plus x cubed over 3 factorial plus blah blah blah, and then you have the dx. So if we distribute that 1 over x, we will have the integral of 1 over x plus 1 plus x over 2 factorial. Let us put the factorial. Anyway, there should be a factorial there to avoid confusion. And then plus x squared over 3 factorial plus dot, 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 and then dx. So if we integrate this, we will get ln absolute value of x, okay, plus x plus x squared over 2 factorial times 2 plus x cubed over 3 factorial times 3 plus dot, 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 and then you have your plus c at the end. Let me put the plus c somewhere here. Okay? But take note, this guy here, the denominator, you can write over 1 factorial times 1. And it's still 1. So the reason is we can rewrite this as a series, as a sum. Okay? It's already a sum, but we write it using the symbol. So this guy here is simply ln of the absolute value of x plus the sum. We start with n equals 1, and then this will be up to infinity of x to the n over n factorial times n. And then you have the plus c. So this is the answer to this integral. So let's look at some improper integrals. So we want to determine whether this improper integral here converge or diverge. So obviously this is an improper integral because as x goes to 1, the denominator here goes to 0. So what we're going to do is to apply the definition first. You have the integral from 0 to 1 dx over 1 minus x squared. This is equal to the limit as t goes to 1 from the left, okay? T1 from the left of the integral from 0 to t of dx over integral 1 minus, or dx over square root of 1 minus x squared. If you remember, this integral here, this is inverse of sine. Okay? So this guy here, it's the limit. As t approaches 1 from the left, we have sine inverse of x. Okay? If you don't remember the formula, of course, you can always use your trigonometric substitution. You let your x be equal to sine theta. So dx equals cosine theta d theta. And then the denominator will become cosine theta. So you will be able to cancel the cosine in the numerator and denominator. So you will just get integral of theta, d theta I mean. So this will give you sine inverse. And in here, we evaluate from 0 to t. So this guy here, it's the limit as t approaches 1 from the left, sine inverse of t minus sine inverse of 0. And note sine inverse of 0, that's just 0. And as t goes to 1 from the left, we'll just get sine inverse of 1. And sine inverse of 1, this is pi over 2. So this is equal to pi over 2. Okay? Next. So in here we have the integral. So determine whether the improper integral is convergent or divergent. So we want the integral from 0 to plus infinity, okay, of e to the x over 5x plus 1 dx. Okay, so you have this integral. What we're going to do is to show that this improper integral is divergent. Okay? And our technique is similar to comparison test. Okay? So how do we do that? So note that on the interval 0 to plus infinity, your e to the x over 5x plus 1, this is greater than 0. Okay? So e to the x plus 1. Also, for x greater than or equal to 0, so for x greater than or equal to 0, your e to the x is greater than or equal to 1. At x equals 0, we have e to the 0, it's 1. Okay? At x greater than 0, you have e to the x greater than 1. Okay? So, the integral from 0 to plus infinity of e to the x over 5x plus 1 dx, this will be greater than or equal to the integral of 1 over 5x plus 1 dx. This integral is from 0 to plus infinity. So we will show that this guy here is divergent, and therefore this must also be divergent. Take note that this guy here is positive. Okay? Because 1 over 5x plus 1, where x is from 0 to plus infinity, this is a positive number. Okay? So to show, the integral from 0 to plus infinity of 1 over 5x plus 1 dx is divergent. Okay? Indeed, we have the integral from 0 to plus infinity of dx over 5x plus 1. Again, improper integral, so we use the definition limit as t approaches plus infinity, integral from 0 to t, dx over 5x plus 1. This is just the limit as t approaches plus infinity of ln, absolute value, 5x plus 1 over 5, evaluated from 0 to t. And this is just ln, absolute value, oops, forgot the limit as t approaches plus infinity, ln, absolute value of 5t plus 1 over 5. And in here, at t equals 0, you'll just get ln of 1, which is equal to 0. And this guy now, this guy here, this is plus infinity. So, integral from 0 to plus infinity dx over 5x plus 1 is divergent. So is the integral from 0 to plus infinity of e to the x over 5x plus 1 dx. Okay? So it's like the comparison test. This is actually comparison test for improper integral. It has its own name. Okay. Next problem here, determine whether the improper integral is convergent or divergent. So integral from -1 to 0 e to the 1 over x cubed dx. So this guy, it is improper because at x equals 0, we have a 0 denominator here. And also we have a 0 denominator in this exponent. So the integral from -1 to 0 of e to the 1 over x cubed dx. By definition again, this is the limit as t goes to 0 from the left, integral from -1 to t, e to the 1 over x cubed dx. And then, what do we get? We'll look at this guy. Okay, we look at this guy. Integral e to the 1 over x cubed dx. We can let u be equal to 1 over x. Let's start with that. And then du equals -1 over x squared dx. Which means this guy here, it's equal to negative integral of e to the u. We'll get 1 over x squared. We'll have 1 over x left. So this guy here, it's u e to the u du. And then we can use your IBP in here. Let's use tabular in here. So you have your u e to the u, and then 1, still e to the u, and then 0, this is still e to the u. So we have here plus, we have here minus. Remember your tabular. If you don't remember this tabular method, you can always use your IBP immediately. But anyway, this becomes minus quantity. You have u e to the u, then minus e to the u. And then you have your plus c here. But your u, it's equal to 1 over x. So this guy here will become negative of 1 over x e to 1 over x minus e to 1 over x. And then you have the plus c. So that this becomes here limit as t approaches 0 from the left of negative quantity e to the 1 over x minus e to the 1 over x evaluated from 0, from 0 or from -1. That's from -1. So from -1 to t. So if we evaluate this, we will have the limit as t approaches 0 from the left we have negative e raised to 1 over t minus e raised to 1 over t, and then minus quantity e raised to negative 1 over negative 1 minus e raised to negative 1. So in here we have, as t approaches 0, we have e to the so 0 from the left. So here you have e raised to negative infinity. So that will become 0, and then here 0 again. So we use L'Hopital's rule for this part. This is 0 over 0. This is an indeterminate form of type 0 over 0. This, of course, will go to e to the 0, and e to the negative infinity, and e to the negative infinity, that's just 0. And then this guy here, it's just number. Okay? So we will have limit as t approaches 0 from the left of negative e raised to 1 over t, and then minus, that's just 0. And then I think I missed the negative in this part, minus the negative of here. Okay. And then, so minus minus, that becomes plus. So you will get plus, but you have here negative e raised to negative 1 minus e raised to negative 1. So this is just negative 2 e raised to negative 1. So for this guy, we use L'Hopital's rule. So L'Hopital's rule, we have the limit as t approaches 0 from the left. Okay, 0 from the left. And then, using L'Hopital's rule, we will have negative e. Oh, before using L'Hopital's rule, I want to change this guy. I want to change this form. Okay, you will see why. If you apply L'Hopital's rule on this part, it will just get worse. So what I'm going to do is to rewrite the expression as 1 over t, and then all over e raised to 1 over t. And by the way, there's a minus here. So we have the minus there. And then we still have that minus 2e raised to negative 1. And in here, we apply L'Hopital's rule. So we have the limit as t approaches 0 from the left. For this guy, we apply L'Hopital's rule. We have 1 over t squared. For this guy, I forgot the negative. So we have negative 1 over t there because I put it on the denominator, so the exponent will be negative. But anyway, for this guy, we apply L'Hopital's rule. So we get the derivative of this. You will have e raised to negative 1 over t. And then by chain rule, we get the derivative of negative 1 over t, which is 1 over t squared. So this guy here will cancel this guy here. And you still have minus 2 e raised to negative 1. And as t goes to 0 from the left, this guy here will just go to 0. So try to check that one. So the final answer will be negative 2 e raised to negative 1. So this will be the final answer to that. Okay? So with the 2 minutes I have left, I'll just set up the integral in here. So we consider the graph of y equals 1 over x squared. And then use the graph to evaluate this guy here. So the hint was find the area of the shaded region above. Okay? Find the area of the shaded region above. Look at this. So I'll just give you the hint and the setup of the definite integral. Why we can just use the area of the region in order to evaluate this. So, in here, you have your integral from 0 to plus infinity. The area of the region, so if we let this to be A, it's equal to 1, or the integral from 0 to plus infinity of 1 over 1 plus x squared dx. Okay? Now, what we're going to do is to solve for x in terms of y. Okay? So we solve for x in terms of y, and then that's the one we will integrate. Okay? So notice, as x approaches infinity, the value of y will just be 0. And then as x goes to 0, or as at x equals 0, y is just 1. So this integral, we can transform this into this integral actually. And in order to see that, so from this y here equals 1 over 1 plus x squared. So we solve. We just have 1 plus x squared equals 1 over y, which means that we have x squared equals 1 over y minus 1. Or this is just what? 1 minus y over y. And therefore, you have your x equals plus or minus 1 minus y over y. So since x belongs to the interval 0 to plus infinity, we just take the positive here. X is simply square root of 1 minus y over y. Okay? Now, if you look at this integral here, okay, this improper integral, it looks like, with respect to the shaded region, it's look like we are getting the area of the shaded region using vertical strips. Correct? So this vertical strip, it moves to the left or to the right. Okay, so to the left or to the right, and then it will cover the shaded region. Okay, but what we're going to do, since we have written, so from the beginning we have y in terms of x, and then we transformed it into x in terms of y. In order to get the same area or the area of the same shaded region using the variable y, remember, we use horizontal strips. Okay, and then we move this horizontal strip upwards or downwards. So the lower limit of integration will be 0. The upper limit of integration will be 1. And when you do this integral here and this integral here will have the same value. So meaning the integral from 0 to 1 of square root of 1 minus y over y dy, this is equal to the integral from 0 to plus infinity of dx over 1 plus x squared. And just try to evaluate this as a practice and you will get this improper integral. Okay?